Welcome back for our final lecture. Today's lecture is called Systems of Equations. You have learned several ways to graph a linear equation. Today we're going to learn about systems of equations. A system has two or more lines that intersect. So that's really our twist of the day. We're going to be graphing not just one line, but two lines that cross. So let's draw a system on the graph or the coordinate plane below. Line 1. Draw a line that connects at points -2, -2 and point 5, 5. Now we only need 2 points to graph a line. So let's begin with this point. Remember, we have x value, y value. X is -2 right here at the same time that y is -2 as well. And here is that corresponding point. The next point, the x value is 5. At the same time, the y value is 5. And where do they meet? Looks like right here. There's my second point. Take your ruler and draw your line. Remember, the end of the line needs to have arrows on it just to show that it is indeed a line that goes on forever. Okay, line number 2. Draw a line that connects points 4, 0 and 1, 3. So x is 4 at the same time that y is 0. So the y value didn't move at all right here. The next point is 1, 3. X is 1 and y is 3. Meets right here. 2 points means that you can draw a line. Very nice. This is our system of equations. Now, we could keep on drawing lines. You can have 2 or more lines to become a system. But for today, we're just doing 2. Now, do you see where the lines intersect? Highlight the intersection. So it looks to me, looks pretty close, not exactly, but pretty close to right there where x is 2 and y is 2. I'm going to assume that that's my point of intersection. This is also called the common solution. Next, I'd like you to graph some lines when you are given 2 linear equations instead of coordinates. Remember, we just graphed 2 lines using the coordinates. Now I'm giving you the linear equations here. This is the first one. This is the second one. You can choose to use the slope-intercept form, or you can use t-charts to graph these lines. And since they're already written in slope-intercept form, y equals mx plus b, I'm going to choose to graph them that way. Now remember, the number in front of the x is the slope. And you have to pay close attention to the sign as well. And remember, the number on the end, or the b, is the y-intercept. And pay close attention to the sign. That's all we need to know to graph 2 lines. Let's do the first one. Y-intercept is -2, and that's a point. Use your knowledge of slope then to graph a -1/2 slope. So rather than rise over run, if it's negative, it's just drop over run. We're going to drop 1 and run 2. Drop 1 and run 2. There's my second point. Connect those 2 dots to make a line. For my second line, I have a y-intercept of -6 this time and a slope of 1/2. And note that it's positive, so it's going to rise 1 and run 2. Rise 1, run 2. I have 2 points. Let's connect the dots and make a line. Here. Now the next question says, can you tell where the lines intersect? Write the coordinates. Well, Here's where they intersect. It's not exactly on. Let's see, my x value looks like it's near 4, but it might be 3.5. I'm just going to guess 4, but I don't feel very confident about that. And the y value, it's a little lower than 4, maybe 4.25 or 4.33, but I'll just go ahead and put -4 since it's close to that. It looks like the two lines intersect at point 4, -4, but how can you be sure that your lines were drawn with 100% accuracy? You can't. Human error means that your lines might not be perfect. We can get a general idea of the intersection by graphing, like I just did, but if you need an exact answer, you'll have to use algebra to solve your system of equations. Next page. So here's where the new notes start. Today I'm going to show you how to solve a system of linear equations using addition and subtraction. Let's work with these two equations. Now I know that these are linear equations because the variables x and y are raised to the power of 1. Same over here. You don't see an exponent of 2 or 3 or 4. But these lines are not written in slope-intercept form, and it's okay to have your variables on one side of the equation. They're still lines. The first step to find the intersection is to set both of your equations up like an addition or a subtraction problem. Just like, back in school, if you wanted to add 41 plus 3, you would set them up vertical like this and then draw a line. We're going to stack them on top of each other just like that. I took the first line, 2x plus 3y equals 20. Then I stacked the next line, -2x plus y equals 4. Now your goal is to get one of these terms to cancel out. You either want the x's to become 0 or you want the y's to become 0 by adding or subtracting them. This is the hardest part of today's notes. Now if you look carefully here, luckily I see a match. 2x here and a 2x here. This -2x is going to allow me to subtract here. 2x minus 2x equals 0. So that was my goal. What you're going to do is add the terms going down here because 2x minus 2x, or 2x you could say, plus a -2x becomes 0. You're adding all of your columns vertically. So 3y plus y, this is really a 1 in front of it, is 4y. Carry your equal sign down. Now add your numbers. 20 plus 4 is 24. At this point, all you need to do is solve for your unknown variable. When you have only one variable in an algebra problem, use the steps that we've already learned to solve it. So I hope you understood that the purpose of this, of stacking them like this and adding, was so I could cancel this variable here. I don't want to solve an algebra problem with 2 variables. I want to leave it with 1. So here we go. This is just rewriting down here what I've already shown you. 0 plus 4y equals 24. You don't need to worry about the 0. 4y equals 24. This is a one-step algebra problem. Since this is multiplication, do the inverse, divide. Remember back when we did that? Divide both sides by 4. 4 over 4 cancels, and 24 divided by 4 is 6. Y equals 6. So for these two lines, you just found the y value that occurs where they intersect. But that's only half of our coordinate. Now we need to find the x value. This is not too difficult. To do this, you're going to substitute the y value into either of the original equations. And the equation that I chose to use was just the second one, -2x plus y equals 4. Now let's make sure everyone's clear where this came from. Do you see it up here? This was one of our lines. So I found the y value. I'm just going to substitute that 6 right in here and then solve the equation. So we said y equals 6. Instead of y, now you're going to put a 6. -2x plus 6 equals 4. This is back to algebra. Here's a two-step problem. I want to get my numbers, my loose numbers on the same side. Let's subtract 6 from each side. That allows 6 minus 6 to become 0. Now I'm down to negative 2x equals 4 minus 6, negative 2. This is a one-step algebra problem. You want to divide both sides then by negative 2 in order to cancel here. Negative 2 divided by negative 2 becomes 1. I can cancel that. Now I'm left with x equals negative 2 divided by negative 2 is just 1. X equals 1. So then the intersection occurs when x is 1 and we said y is 6. That's how you can find the exact intersection or common solution. Next page. So let's try then using one that involves subtraction. Let's work with these two linear equations this time. Y equals 2x plus 3 and y equals x plus 2. Now notice for these equations, y is by itself and the x is on the right. This is slope-intercept form. That is fine. You can do these math problems either way as long as it matches. You need to make sure that it looks fairly similar so that when you drag the equal sign down, they were stacked on top of each other. So in other words, you wouldn't want to have one linear equation that looks like this and then another one, say, that looks like this, x plus y equals 2, or something like that. You need to make sure that when you have one variable on the left, that it matches the other one. And if not, you have to use your knowledge of algebra to rearrange a little bit. So here are my two equations. Stack them on top of each other. Y equals 2x plus 3. That was my first one. Now stack y equals x plus 2. Now on the last page, we looked carefully at it and we said, is there any way I can add these in order to cancel out one of my variables? Well, if I add y and y, I'm going to get 2y. That's not going to cancel. If I add 2x and x, I'm going to get 3x. That's not going to cancel. So in this case, you're going to have to use subtraction. Luckily, my y's do match. The coefficient in front of them is a 1. If I just subtract my second problem here, my second equation, I'll be able to cancel. Y minus y would be 0. So let's look a little bit closer here. How do you do that? I want to subtract the entire second problem here. So make sure when you're going through that you say y minus y, then 2x minus x, and then 3 minus 2. A lot of students really struggle making sure that they don't ignore this negative sign that should go throughout the equation. Okay, and then in the next section here, just to remind you, I went ahead and put a negative on each one. Y minus y becomes 0. 2x minus x becomes x. 3 minus 2 becomes 1. That doesn't look too difficult to solve, does it? If I can get this 1 over here to the left, I'll be done. So subtract 1 from both sides. This will cancel. Now I have negative 1 equals x, which can be just flip-flopped, right? You can always move what's on the right to the left if you do the whole thing. So just flip it around. X equals negative 1. That is the x value of my coordinate of intersection. So then how do you find the y value? Remember, you substitute whatever you just found into either of the original equations. Let's pull one down here. I'm going back to the top and finding y equals x plus 2. That was my original equation. So I'm going to take my x value here and substitute it for x. Then it would look like this. Y equals x is negative 1 plus 2. Y equals 2 minus 1 would be 1. So what do you get for y? You get 1. Now, the intersection occurs at point negative 1 and 1. So we did one of these systems using addition, and we just did one using subtraction. Oops, wrong one here. This is the right one. So let's graph this system of linear equations and then solve it using addition or subtraction. So we'll have to figure out which we want to use. It does say to graph this one first, so let's go ahead and do it. I think probably we could do a t-chart, but let's go ahead and arrange this into slope-intercept form. Y equals mx plus b. So how do I get my x then on the right side? Subtract it from both sides. This becomes y equals negative 4x plus 10. That is the line that I want to graph. Get my highlighters back out for you. My slope is negative 4. My y-intercept then is positive 10. Let's go ahead and graph this. Y at positive 10, and my slope is down because it's negative. Down 4, and what's the run? Anytime you have a whole number, remember, you can put it over a 1. So down 4, run 1. 1, 2, 3, 4, run 1. And those are my 2 points. Use my ruler to make a line. There we go. Arrows on the end. That was my first line. Second line, same thing. I'd rather see it in slope-intercept form. I just prefer it. Let's go ahead and move the 5x to the right side by subtracting 5x from each side. This can cancel. Now I have negative y, don't forget that there. Negative y equals negative 5x plus 8. This sometimes confuses students. What do you have when you have a negative y? It's not very difficult to change. There's 2 things that you can do. When you have a negative y on one side, you can say, let's change the signs for everything. This becomes positive, this becomes positive, and this becomes negative. That sounds too easy, doesn't it? So how did they do that? Well, remember that whatever you do to the left side, you do it to the right side, and then it's still an equal equation. So just multiply each side, basically, by negative 1. That's what you're doing, multiplying by negative 1. Negative 1 times negative y becomes a positive y. Negative times a negative becomes a positive. Negative times a positive becomes a negative. So that's our new equation. Get our highlighters out. The slope then is 5, and the y-intercept is negative 8. And we're ready to graph. Y-intercept at negative 8, way down here. The slope then is 5 over x. That's rise 5, run 1. 1, 2, 3, 4, 5, 1. Very steep line. These are 2 steep lines, aren't they? Okay. Connect your points. Put arrows on the end. Can we make an estimate of what our intersection is going to be? Here's the intersection, or the common solution, right there. I think we got pretty close. I think the intersection is going to be at x is 2 and y is 3. If I did it right, let's see. Well, we'll have to see if we did it right. This will be good for us. The next step then is to graph, is to use your addition or your subtraction by stacking them on top of each other and then seeing if you can cancel anything. I'm just rewriting my 2 equations, stacking them on top of each other. Can I use addition or subtraction to cancel out one of my variables? And it looks like I can here. Positive y added with a negative y then becomes 0. So you're adding. You're going to add every column, drag your equal sign down like this. 4x plus 5x becomes 9x. Plus y and minus y becomes 0. Drag your equal sign down, and then 10 plus 8 becomes 18. Now I have 9x equals 18. Solve a one-step algebra problem here. x equals 2. Okay, so it looks like I got my x value correct, doesn't it? The x value is 2, but let's double check that y value because I'm not sure I did that right. Once you have found one of your values, all you need to do is choose one of your lines then to substitute the value back into. And it doesn't really matter which one. I'll just choose the first one this time. In place of my x, I'm going to write a 2. So my equation that I'm using is 4x plus y equals 10. But I want to substitute right here a 2. So 4 times 2 then would be 8. Everything else stays the same. 8 plus y equals 10. To get rid of my 8 over here, subtract 8 from each side. Y equals 10 minus 8, 2. Aha, so my estimate then wasn't correct. I was off by 1. So this is actually a great example for you. Graphing by hand can give you an estimate, but it's not exact. You have to solve the system of equations using addition or subtraction like this to get the specific exact answer. So then the y value is 2. This is the common solution for these two linear equations. Now, if you want to, I haven't highlighted in yellow down here, you can double check your answer by plugging both of the numbers in for the x and y values in either equation. The numbers on both sides of the equation should then be equal. So let's go ahead and pick that second equation, 5x minus y equals 8. Let's pick that one. So use your x value of 2 and your y value of 2. That would be 5 times 2 is 10 minus 2 equals 8. Is this true? 10 minus 2 is 8 equals 8. Absolutely. So we are 100% certain that the point of intersection is 2, 2. All right, last page. On this page, I have 2 practice problems for you, and I'm not asking you to graph this time. It just says, find the intersection for this system of linear equations. Y equals negative x plus 7, and y equals 2x plus 1. So I'd like for you to go ahead and pause the video here and do this first problem by yourself. Okay, let's get back together now. So I see 2 linear equations. Luckily, they're both in a matching form. Y equals mx plus b, y equals mx plus b. Good. So let's just stack them and see how they look. Y equals negative x plus 7. Y equals 2x plus 1. Okay, draw your line. If I add my variables, y plus y would be 2y, negative x plus a 2x. Let's go ahead and put a 1 here. 2x minus x would then be 1x. We could do that. But I think, let's go ahead and subtract though. Let's just subtract. Subtract the entire equation. So y minus y would be 0. Negative 1 minus 2 would be negative 3x. And 7 minus 1 would become 6. All right. Let's go ahead and subtract 6 from each side. That leaves me with negative 6 equals negative 3x plus 0. At this point, it's a one-step algebra problem. Divide both sides by negative 3. And I have x equals negative 6 divided by negative 3 would be 2, positive 2. So I think that that is the x value for the point of intersection. So once you have one of them solved, plug it back into either equation to get your other value. So let's go ahead and plug it in here. Right there. Now it will be y equals 2 times 2, 4, plus 1. Y equals 5. So I think my point of intersection occurs at 2, 5. And how can you be sure? Plug it into either equation and make sure that both sides are equal. All right, let's plug it into this one here. Y will be 5 equals negative 2 plus 7. Let's see. 5 equals 7 minus 2, 5. We got it right. This is 100% certain that 2, 5 is the point of intersection. Now the last one that we have here is a little bit tougher, and you'll see why in just a minute. But same concept though. Find the intersection for this system of linear equations. We don't have to graph, which is nice, but we do have to stack them. X minus y equals 5. 3x plus 2y equals 0. Draw your line. Okay, go ahead and take a good look at that now and see if there's any way you could add them to cancel a variable or subtract the second problem to get a variable to cancel. Are you stuck? If you can't get any of the terms to cancel, what you're going to have to do is manipulate one of the equations by changing it. Like for instance, I'm going to be multiplying my first equation. Multiply both sides of the equation by some number. And remember, what you do to one side of the equation, you just do to the other side of the equation. As long as it's the same thing, that's an equal equation. I could multiply this equation by 3, or I could multiply this equation by 2. And I hope you can see why I should pick this one here. Right now I have a negative y. If I multiply the whole equation by 2 on both sides, this will become a negative 2y. And then I can just add, can't I? Let's go ahead and do that. Bring it over here. Multiply 2 by this entire equation here. 2 times x becomes 2x minus 2 times y becomes 2y equals 2 times 5 becomes 10. I just want to make sure that you understand that x minus y equals 5 is the same thing as 2x minus 2y equals 10. And you can kind of take a look at that and see, well, I can reduce these, right? If you divide both sides by 2, excuse me, you'd be back to your original equation. All right, let's bring the other one down. We're not changing the other one. You only manipulate one of the equations. 3x plus 2y equals 0. Now, I'm going to add. Make sure I have my plus sign. You're going vertically. 2x plus 3y is 5x. Negative 2y plus 2y is 0. And that was the goal, to get one of my variables to cancel. 10 plus 0 is 10. Rewrite. 5x equals 10. This is a one-step algebra problem. 5x, divide both sides by 5. 5x over 5 cancels, becomes x, equals 10 divided by 5 becomes 2. I think my x value at the point of intersection is 2. So how do we find the y? Plug your 2 back into either problem. This one just looks a bit easier then, so let's go ahead and try that. X minus y equals 5. I'm going to use my 2 here, put it right there. 2 minus y equals 5. Okay, let's go ahead and subtract 2 from both sides. Don't forget, you got to keep your negative here. Negative y equals 5 minus 2, 3. Go ahead and multiply both sides of this equation by negative 1, or some people say, hey, let's just change the signs, which is actually what it's going to be. If you multiply both sides of this equation by negative 1, you're going to end up with y equals negative 3. So I think my point of intersection then is 2, negative 3. How can I be 100% sure that I did all the math right? Plug it back into one of the equations. And let's go ahead and use the other one. Let's use 3x plus 2y equals 0. In place of x, I'm going to put 2. In place of y, I'm going to put negative 3. Here we go. So 3 times 2 would be 6, plus 2 times negative 3 would be a negative 6, equals 0. 6 plus a negative 6 becomes 0, equals 0, and that is true. So I'm 100% certain that my common solution, or the point of intersection, occurs at 2, negative 3. Now I will tell you, these can get very, very difficult. in our class, we're only going to be manipulating one of the equations, but sometimes you have to manipulate both of them to get your variables to cancel. So I realize this was a little bit challenging today. I would strongly encourage you to rewind and watch this again. Thanks.